Hello, I'm Mehrdad Simkhani, your calculus professor, and this lesson is about the net change and the fundamental theorem of calculus. Let's say we have a function y equals f of x. The question is, how do we express its net change from x equal to a to x equal to b? So we can picture it on the x-axis from a to b. And here we have the rate of change of f prime. And that means the change in f over the change in x is f prime. So if we multiply that by delta x, which is the change in x, that gives us the change in f. So the change in f over that small interval would be the value of f prime times delta x, which is the area of this tiny rectangle. And the total change, or the net change from a to b, is to add up all these little changes. And we learned that integration answers that question. If you integrate from a to b of this expression where delta x is replaced by dx, here delta x tends to 0 as we decrease delta x and increase the number of rectangles, we more accurately measure that area, which is really what we are after here. So the net change of f from a to b is integral from a to b of its rate function f prime dx. Here's another way to see the net change. Simply, if we evaluate f at the right endpoint at the final value of x minus the value of f at the initial point, the left endpoint of the interval, that difference is the net change in f. And guess what? Net change is the net change. So that means these two quantities must be equal. Integral from a to b of the rate function f prime of x dx equals the value of the amount function at the upper limit or the right endpoint of the interval minus its value at the lower limit or the left endpoint of the interval. And this is what we call the fundamental theorem of calculus. Let's take a quick example. Here's the integral from -1 to 2 of 3x squared dx. We know that 3x squared, if we call it f prime of x, then f of x would be x cubed, right? Derivative of x cubed is 3x squared. So by the fundamental theorem right there is to evaluate f at b minus its value at a. So this would be 2 to the power 3, so x is replaced by 2, minus -1 raised to the third power. And when you simplify, this is 8, -1 to the third is -1, with the minus with +1, so I think you get 9. The more systematic way of writing this when you're solving this integration problem is to say this is equal to, write the antiderivative x cubed, this is without c, and then we put this vertical bar at the bottom. We have -1 at the top, 2. This notation means to evaluate this function at the top, and then, oh, I get this backwards. So to evaluate this at the top, so x is 2, so this to the third power minus, now plug in the negative 1 to the third power, and then simplify. So this is the notation we're going to use when we solve these integration problems. Here's another problem. Suppose oil is leaking from a tank at the rate of K minus mt. K and m are constants. T is time, the variable. If the initial amount is 100 gallons, how much oil will be in the tank 5 minutes later? Let's say T is measured in minutes. So the excuse me, the answer is starting with the initial amount, and then from that we subtract how much oil leaked during these 5 minutes. So, and that is the net change in this rate function. So this is the rate. K minus mt is the rate function, and we are measuring that that net change, the net change into the amount from 0 to 5. So the amount of oil leaked is this integral from 0 to 5 of the rate function K minus mt dt. Here our variable is t, and that we can easily solve. Find antiderivatives. K is constant, so you get K times t. T is a variable, minus antiderivative of mt would be half m times t squared. You can see this from the power rule. 2 times m over 2 is m, and then you reduce the power, so you get that. So that's how we check. And the derivative of kt is just k. So this is to evaluate at 0 times 0 at the beginning, and at the end 5, and subtract. So this is equal to 100 minus, plug in 5 for t, so you get 5k, minus m over 2 times 5 squared, which is 25, and then minus, plug in 0, minus 0, and then minus of the other 0, which is really plus 0. We don't need to write that. And then simplify, and you get 100 minus 5k minus 25m over 2. And this concludes the video.